The flux gets bigger, doesn't it? If the flux gets bigger, it'll produce a current opposite to the external B field.
Okay.
And that means it must go that way because the external B field is that
Oh
way.
yeah. Okay. All right.
So boom, boom, it would go clockwise in this
Like the
situation.
hand thing,
Yeah.
this goes out to where the, this goes where the thumb is.
Makes a lot more
No.
sense the third time you explain it.
No, it is because there's all kinds of words that you won't catch the first time. You know what I mean?
Yeah.
And okay, everybody. Now let's do another problem, and then I'll let you guys go because you're almost there when you know what you're doing.
Yeah.
Turn the page. There's that problem there. You know what? They don't make that a problem, but I'm going to. Let's do this. You know what? Let me see if I can find one because I know I can. Let me check out the C book real quick. Here, let me see this. Well, I'll tell you what. Let's do this, and then I'll let you out of here.
What is BLV?
That's what I want to go. You know what?
That's the current in the wire or something.
It's the voltage.
Voltage.
Let's do this. You know what? I don't need a problem to do this. We'll just. Why to do that? I need that.
I do.
Well, yeah. There we go. We're good. All right. Ain't I smart?
This has to go in your YouTube.
We're saying the length of this thing, of the bar, from here, not the whole bar, but from that track to that track, is going to be L. Okay. Furthermore, the thing is going V, speed V that way. Okay.
Wait,
Right?
what's going the bar?
Yeah.
Oh.
It's sliding with a speed of V that way. And I want to know. Let's see if we go on this. I want to know what does the voltage produce in this situation.
So that the V is how fast you're going.
Huh?
The V is how fast.
Yes. Yes. It's not, I notice I didn't say it was a vector like velocity. I kept it simple, just said it was speed. Because that's all you need on this thing.
Oh, is that why it's delta A here? Because your area is changing. If you're
That's
working.
exactly, yeah.
Okay.
And it gets simple really quick. And so here's what you're going to do.
Why is it over time though?
Well, it is. You just don't know it yet, okay?
Oh,
Just let me do it.
Because
Alright.
it's meters per second.
Now, guys, I'm going to absolute value on this thing because the only thing that the negative sign about is Lenz's law. And you understand whether it's going to go clockwise or counterclockwise. You with me? And AP allows you to do this. Just you just say this. Absolute value of, and they're good to go. You know what I mean? All right? Because the negative sign has nothing to do with the math. All right? So do this. And it ends one, so that doesn't matter. And we'll do this. And let's get that. It's not very hard. Yeah, shoot. Here we go. Now, we're going to do delta M. It's going to be B, A, cosine theta, delta T. That's 1.
Wait. How is this any different from the one we just did? Oh, because the area's not getting any bigger. Never mind.
And the one we did, this one's getting bigger. Oh. Is this an actual problem here?
Well,
or-
actually, it's very similar, but it's a different application.
Yeah.
It's
It
pretty
is very similar.
Like, it just one
We want to do one where the B field changes next time.
Yeah.
All right? On this one right here,
Well, the area is getting smaller now. So
Yeah.
it's kind of the same.
it is, but I want to do this because they use it a lot.
Because you have to use velocity too. You
Yes.
have to use velocity.
So let's do this. So we have this. Now the B field is not changing, so B comes out.
So you have B delta A
Now,
So
over delta C.
this equals, and we know this. This is going to be, how do I want to say this? Let's call this X, as opposed to the X just below it, okay? From here to here is X. You with me? So let's do this. So the area is going to be this, right? So it'll be X times L.
it's going to make it bigger.
Yeah.
So you have to know how far you're going.
You with me so far? And I'm going to do this. Oh, yeah. Here. So this. So B, and the L doesn't change, does it?
No.
So we bring that outside. We have this. Right? And what's delta X, delta T? Speed. Speed of the bar. So therefore this does equal B, L, V. That's the voltage in the thing. Make sense?
Wait.
Do you need to study the negative n?
Oh, I don't even care about the negative at this point anymore, because I know it's about Lenz's law.
You still need the amp.
Oh, well, there's only one turn. If there's more than that, you need it. All right?
Just leave it as
Wait,
is.
so, hold up. Why isn't the delta T over the BL2?
It is.
Well, it is. But this is BL. If you put it that way, this is V though, isn't it? Delta X over delta T, right?
Oh, so it's just the same.
It's not like they're adding them.
Yeah.
You can take it out.
Oh, okay, I see what you did.
All right.
Why are y'all here?
Well, we're back now. Is Jack going to cancel?
Why?
Now, let's do one where, now, and this, and IB allows you to use, anytime you see a flying bar, I don't care if it's an airplane wing, the voltage across this wing is going to be a BLV. And I'll show you that later. Right now, I want to go to another application, okay?
So, if there's always a bar, the voltage across it would be DLV.
It'll be BLV, where
Mine
yes,
is going through a magnetic field,
as long as it's going through a magnetic field.
which is always because there has a magnetic field.
Yeah. It's very strange that it works.
Like right now, which way is the Earth's magnetic field going?
Oh, it's to the north.
That way?
No. It's the north is that way, or that way.
When
So
was
can I
it-
just like swing a bat and it would create voltage and I just wouldn't realize it?
If it was a metal bat and it was a really big bat, yeah.
Okay.
I mean, you know. Okay, guys. I mean, it would a small
Why did I
bat.
say, why did I point up for north?
Yeah,
Okay.
so I was like 8.
No, it's
Uh,
always in front of me.
Guys, let's do one more where the B field's changing, okay? And then I'll get you out of here. So let's say this. Let's say you have a coil, and let's say N is equal to 10. 10 turns.
What is that? Shut up.
It's a circular coil of wire.
Okay.
So there, and let's say the raise that thing equals, it's
Oh,
too-
you know what I did that was really stupid on the AP test, or the IB physics test? I mixed up my equations for circumference and area.
oh, really?
Yes. Like
Okay.
twice. What?
Were you ready to use this?
I
Yeah.
never used them.
I did for R equals rho L over A. I think it was the sixth problem.
Let's see.
Yeah. What was the student?
That was on there?
Yeah. That was on
Question
question
six.
six.
Like, I didn't.
Yeah, y'all did like 5, didn't you?
Oh, the first response. Okay, I think that's
Thermal
it.
energy question.
You did?
I accidentally put. I didn't put negative. I got 93 instead of 66.
Oh, that sucks.
Did you get 66?
I don't remember what I thought. I think I didn't make some math there in the middle, so I stopped it because I didn't know
You did them?
something was wrong.
Yeah, did you?
But I think I did like the first.
Because you had to do the rho L over
Yeah.
whatever.
I actually think I remember that, but that's wrong.
Dang, how many givens are there?
So I want to know the voltage and I want to know the current in that thing.
What's that?
Now write down and we'll talk about it, make sure you understand, okay?
So you're just like moving a
All I'm doing is, the B for, I'm gonna have it coming out for a change, you know what I mean?
Yeah. Oh, it's going out of the page too.
And guys, I'll put this online tonight where you can watch the video if you want to. All right, and I'll put a few more in here.
So far the work list is watch the videos on fluids, watch the video you're about to put up tonight. Anything else?
Do a bunch of AP tests. Free response.
Yeah, as many free responses you can do.
Did you make our,
Yeah, should
did you
be
get our free response?
a multiple choice anyway.
Multiple
Good,
choice, that's all I meant.
Mine's kind of central, so I figured if I wanted to.
Yeah, sure they are.
Big bottle in the morning and something like that.
Yeah, that's 2004.
How big up was it? How big is
back to?
But because of we come back alive.
How big is wrong?
I know.
All right, guys, ready to go?
Yeah.
Now, so I'm gonna do this.
Like, we could all have room, I have to look.
I was gonna put it down here, but I was like, nah, this probably won't be it.
Okay.
So the A comes out, so it's just.
Yeah, well, let me break it down.
E equals 10 times 0.0.
All right, yeah, and the A and the cosine theta come out. Of course, the cosine theta is 1, right?
My mommy's calling me.
So do this. That's 1. Yeah,
Hello? There? Physics? It's school. Yeah. Oh. Yep. Hey. Hey.
we're almost there.
We're almost
Wait, so in this one, our B field is changing?
Yeah, it went from 2 to 0.
Oh, okay, great.
Okay.
She just hung up.
Now, I'm gonna say this, so this is gonna be, were there 5 turns? How many turns were there?
10.
10. It was 10?
10.
Yeah.
I'll take your word for it. So, and the area is gonna be pi r squared, right?
Yeah, sir.
And this is gonna be, and then b, final minus b initial, which is gonna be
Negative 2.
0 minus 2, right?
Yes.
And all this is over.
0.2.
All right, plug it in, see what you get.
What's our? Oh, you gave us an R.
Can't you just get rid of the negatives? Well,
Yeah, when it's all said and done, yeah. It's absolute value of anything and everything.
Oh, okay.
because are you ever gonna have a negative voltage?
That's possible.
Well, once again, we don't turn whether it's negative or positive until we do Lenz's law.
Yeah. But even if it's going counterclockwise, it's not a negative voltage.
I don't know what it is, but it's counterclockwise. That's all I care about.
Okay.
What, did anybody get this?
No, I don't have my calculator.
Okay.
Yeah, I don't know.
All right, just a sec.
I'll just go do it. That's too much to do on that crappy calculator. How do you
This
use-
one?
How do you use
I don't know how to
that?
use
Oh, in many ways, I enjoy these more.
You're a magician.
Yeah. I remember I forgot my calculator once last year and I tried to use it and I didn't know how to.
You have to press like the square button before you press the term in. It's confusing. I don't know, you just go-
Ashka, I got 1.1. What'd you get?
1.1.
Whoa, you're.
All right, now we want to get the current, don't we? So that's V equals IR.
I did buy it.
And it doesn't always catch my key.
And you're for I, which is.
What was it, 5.0 ohms?
Yes.
So what's that, 0.19? Is it that or 0.21? It's 0.21, I bet, isn't it?
I think I get 0.9.
Yeah. Is that correct? Well, let's plug it in.
Is this, are we studying tomorrow?
Yeah.
I won't be
There's
here
tutoring
tomorrow.
tomorrow? Because I don't know if I can come tomorrow.
What's tomorrow?
After school?
Friday.
I can't.
0.22.
I can't come tomorrow after school. I have work.
Well, just take care of business then.
I
Is that
got
just another video we need to watch?
Well,
tomorrow. There's
at
nothing
this
to do
point, what you
anymore.
guys can do is, once you understand Faraday's law on fluids, the guy does, I think, a pretty good job on fluids. He does homework. He does example problems. But study them and know them. And do that worksheet that I gave you over fluids.
Okay.
And this is Faraday's.
Yeah.
Is there more Faradays that we're doing?
This is about it.
Get over fluids?
Once you understand what we're doing today, that's Faraday's law.
What are we gonna do tomorrow?
What worksheet did we get over fluids?
I think you emailed it. Did you email us the question for fluids
I emailed you the worksheet.
recently?
Well, probably not, but I can always email it again.
Really?
All right, that's guys that got on this. Let me turn this thing off. That's Faraday's law.